Hello, this is Russ Anderson. In this tutorial, we're going to take a look at rolling shutter, what happens, and what you can do about it using the new rolling shutter system inside of SynthEyes. So in this particular shot, we're going to start out just with some perfectly conventional, traditional cleanup work. The shot was just a tripod type shot. Perhaps we've got a car flying off the edge of the bridge, whatever. So let's say that we've got the camera on the tripod, and we'll run the auto tracker to generate a whole field of trackers. One thing we'll throw in just as a bonus here is we'll run a little script that's randomly color trackers. And so that's going to make a much more colorful view, and it shows some more of what's what. And it's handy when you've got a lot of trackers coming and going at the same time. So with our shot and our cleanup, we're going to start out just taking out the trackers that are out on the clouds. Those aren't really going to do anything helpful for us. And we'll also look around down on the cars. Got some cars driving. You'll see that there are two trackers on that car. There's actually one on the background here. So now we've got something to be able to go and run a solve on. You can see we have a pretty high error number. So let's go take a look at the tracker cleanup panel. You'll see it's saying that we've got 59 high error trackers. So basically everything's horrible. So let's see if that's due to a cause that's specific in the tracking, or if it's just due to the rolling shutter, which is what we've got here. So just increasing this error number, we see that there are a couple of high error trackers. Let's just take a look at what we've got. I think we needed to do one other thing while we were there. That'll be select them. See, look, there's one sitting here on the bridge. If you look and see, it's actually hopping along that repeated texture on the bridge. Similarly, there's another one down here that's moving around on some of those cars. So we're going to take the expedient approach and just hit the delete key and resolve again. So now we have something that's sitting down around 2.3 pixels of error. So the tracking is, reasonable, but the error is still high. And that's due to the rolling shutter. So let's go now and we go out to the shot panel, and we're going to turn on the rolling shutter button that tells SynthEyes that this shot was taken with a camera with a rolling shutter problem. And there's this value that we need to know for the camera if we want to do this super accurately. As a practical matter, something up over 0.9 seems to be pretty good. And it's actually pretty hard to measure this accurately anyway. And that's sort of the subject of a different tutorial. So we're just going to go with a default value there that's based on old NTSC for that matter. And now we're going to go and rerun our solve. And now presto, we're sitting down under 9/10 or around 9/10 pixel. We can run the cleanup now and maybe take a better look at what we've got at this point. Well, we're still seeing a bunch of ones. So we could maybe do a bit of a little bit more cleanup now at this point. And the point is, now that we've adjusted for the effect of the rolling shutter, now we're exposing what are the actual tracking problems that we need to clean up. And we're not getting everything just corrupted by the big effect of the rolling shutter. So now I just deleted those and resolved. So now we're being left with the effect of the rolling shutter in the shot. So let's just take a quick look at that in detail. And I'm just scrubbing through the shot looking for some spots where the camera's moving fairly rapidly. So let's look up at the top here. The X mark is the position of the tracker as calculated by SynthEyes at the time that corresponds to the middle of the frame. The actual 2D tracker, of course, is where SynthEyes actually found it. And you'll see that, they're in a much different position. You'll see how big of an effect this rolling shutter is causing on the shot. If I scrub back and forth a little bit, you'll see that the actual features are moving up to the upper left-hand side. So things are just kind of sweeping up this way. So at the early part of the image, the top part of the image, this feature was actually caught earlier in its path that way. So it's out leading basically the actual 3D position that corresponds to later in the shot. And just the other way around, down here at the bottom of the shot, you'll see that basically the X and the diamond have reversed themselves between the two. Here we've got the X at the upper left, here we've got the X at the bottom right. And that's because the feature again is moving up to the upper left. So by the time that the scan point in the camera has reached the bottom of the shot, the individual feature is that much further along its path, so it winds up being to the upper left of the actual tracker location that corresponds to the middle of the frame. So now, if you look at the middle of the frame, you'll see that things line up pretty well, because there's no error in the timing of the camera. So that just gives you a little idea of what's going on and what a significant effect rolling shutter can have on shots. So what we need to do to this shot now, we can export it to another package, and when we go to add computer-generated effects into the shot, we need to do that with a form of motion blur that simulates the rolling shutter also. And some packages can do that. That would be like RenderMan, and I think you'll see that there will be some more available soon. It's basically another form or modified form of motion blur to accommodate the rolling shutter that the camera does. And the advantage of this approach is that we don't have to do any resampling on the image. It's basically treating it as a form of lens distortion. So there's no resampling to the image that would reduce its image quality. And that this approach works no matter how we have things moving around in the shot. So we can have different cars driving in different directions and so on. And those all get subject to different amounts and degrees and directions of motion blur. And that's very challenging if you try and remove it from the images and kind of fix up the images. People have tried to do that. They wind up doing a lot of hand paint work later, and that's not really very fun. So here, the SynthEyes approach, let's take with the images that we've actually shot. We'll stick with those. We'll get our CG effects to match up with those as shot images. So that's what this is about. Thanks.